Not using good data.
So, all right. So we've talked a lot about, in theories and this, and when it comes down to what do you do as an aircraft mechanic, I think we're kind of moving more into that. And so what we're talking about now, and you've had a lot of questions about this, selection of wire. I should preface this by saying I'm working on my airplane and I need to replace a specific wire. Maybe it's just the nav light wire going out into the wing. How do I select that wire size? Look at the manual, see what the aircraft manufacturer put in, use the same one. It's not that hard, you would think. But working on, now I don't want to say Harry's plane, because Harry actually has a 182 also that's a year newer than mine, but he has a 140, which is one of my favorite airplanes. That's built back in the 40s, and the manual for that book is just, what is it, 30, 40 pages at the most, and half of those are just, advertisements. And there's not a lot of information. I think there's a wiring diagram, or it might even be separate on that book, but Harry's going to rebuild his, and he's going to put in a transponder. Didn't come with a transponder. You're going to put in, some other radios. All the stuff you can make more modern didn't come with. So you have to figure this out. And that's something I did a lot of, rebuilding old planes. And you have to figure out, like I said, you're going to do a schematic. You're going to turn that in the FAA. You're going to, on the 337, you're going to have to figure out wire runs, voltage drops. You're doing this stuff. It's not that uncommon if you're doing restorations or working on older aircraft. So, yeah.
Wire runs?
How long the wire is.
Okay. Thank you.
Yeah. Okay, aircraft wire. So what is aircraft wire? Where do you get aircraft wire? Well, any aircraft Napa store should have. Yeah. Okay, wire is sized by American. That's with an A, not American. It's American. American. Capital M. American wire gauge, or AWG. Based on the cross section size of the wire. That means its thickness of the wire, and that's the metal part, the wire. So 2 zeros, how do we say that? Double aught is about the largest size you're going to see in aviation, about the largest size.
Just use that one for everything.
That would be easy, wouldn't it? When we do AC, I'm going to tell you why you don't. 24 is about the smallest. Everything that goes in an aircraft is, I can't say everything. When you use stuff in aircraft, it's approved stuff. That's not a very technical way of saying things. But I want to replace the battery in my aircraft. I can't go down to, you worked at Napa, right? I think that's where I'm stuck. I got Napa stuck in there. I can't go down to Napa or Walmart and get it, well, I can, but it's illegal, and get a battery just because it fits and put it in my airplane. I can't. I've got to get a battery that's either made by Gill or Concord these days. And they have what's called an FAA PMA, Parts Manufacturing Authorization. And then I would have to look at a table that says that this battery is approved for the Cessna 182 before I can buy it and put it in, right? If I want to buy a light bulb, I can't go down again to Ace Hardware or something, get a light bulb. It's supposed to have this FAA PMA stamp on it. As crazy as it sounds. Everybody's going now to LED lights. Well, I can't just go out and buy an LED light for my airplane. I can go to Aircraft Spruce and Specialty, and they sell LED lights that'll fit right in my airplane. It says right on it, for experimental use only. I have a certificated aircraft. I can't get that. I have to get a certificated aircraft LED. It's probably the same one, But this one has got the approval. This one doesn't. This one costs $20, $30. This one costs $900. Yeah.
Question about the wires. So it says about the largest and about the smallest. Now, is that like is there bigger? Is there smaller? Or is that like the average range?
So when I'm doing my research to find things like this, I will see a statement that says it's about. And so I like to use the term about because I don't want to say double aught is the largest. And then somebody comes back, hey, man, I saw triple aught.
Okay.
You know, you lied to me. So I go, oh, no, I said it's about.
Okay.
I've seen 28 gauge.
Okay, so, and he's seen 28. 28 is really small. And then when you get into 28 gauge, there's special rules and stuff about using wire that way because it breaks so easy.
Yeah, it's
So-
like, what's it called? Encoders. It's like a little chip, basically, that goes into your Garmin unit.
Is it inside of something?
It's in your Garmin unit.
Oh, it's inside of a unit. Okay, so
Inside-
that doesn't
inside
count.
D-cell connector.
Okay, but inside of a unit wouldn't count. This is external wiring stuff.
I've got a remote wire on my subwoofer that's literally like 6 strands of different wire.
Subwoofer in his car, his airplane. Okay.
Got some kickers in
Okay,
there.
so where I was going with that whole statement is, so some stuff is actually FAA, PMA, or approved parts manufacturing authorization, but other stuff is not necessarily. Like if I want a bolt for my airplane, well, again, I can't go down to Hollywood Hardware, which is a great hardware store here in town, over by Freeport, and get a grade 8 bolt. I need an AN bolt, an aircraft bolt. It either has an AN number or an MS number. So if it's got a mil spec number, there you go. Like seat belts. Seat belts don't necessarily say FA, PMA, but they have a TSO, a type certificate order. Technical standard order. There you go. I'm like, I know I'm wrong. Technical standard order. So some things are made to a TSO, technical standard order. I was looking at in my 150. I was going to replace a nav radio, and there's a company that makes nav radios, and they have this big thing on there that our radios are made to a technical standard order, but they're not approved under a technical standard order. They have this big old long web page about why that's okay, and I don't want to get into that. But so a lot of things are made to a TSO. I think all aircraft instruments, Garmin and all that, are TSO. So it's not FA, PMA approved, it's TSO. So you got to have something in there, mil spec, TSO, or something along that line. So that's why you can't just go out and get wire. So approved wire, and I use the word loosely here, approved. I should say acceptable wire. I should prove acceptable. Acceptable wire is generally mil spec. Mil spec. And it's easy to identify. It's white, almost always. Doesn't have to be, but it's usually white with green letters on it. And this stuff is just tough as nails. It's got a Teflon coating on it that's actually kind of hard to work with. Mil W 22759 is the most common. 22 mil dash W dash 22. That's not on the test. Usually white. It's rare to see anything other than white, but it's there, although it doesn't have to be. It has fluoropolymer, otherwise known as Teflon. Teflon insulation.
So if it's all white, how do you know what you're wiring up?
You guess.
Keep track of it, right?
Well,
Label
wire
it, keep
numbers-
track of it.
Bundle of wires.
Wire numbers.
Wire numbers. It's hard though when you just buy a big spool of it and it's all got the same number on it.
Yeah.
Yeah, you pay attention. That's what you do. You label it.
Yeah, usually the green letters have the 22 gauge.
It has the gauge on it, so that is nice. So it'll say like mil W22259-12, right? That's your 12 gauge. So it has a dash number on it, tells you what gauge it is. it is also stamped for what it is in a lot of aircraft. It hasn't been changed out. So it is identifiable by stamping on the wire as to part number and size. Like I say, inside of an aircraft, sometimes it'll be stamped as to the system that it is. Now, it's not going to say radio, but it'll have part numbers or system numbers on it that you can identify through the manual. Modern wire is copper with a coating. I got to move up a little bit. Coating of tin, silver, or nickel. So tin, silver, or nickel. Now you have to be careful because that's just two eyes, too many eyes there. Some older wire is aluminum, and oh, that stuff is not great. So older wire is aluminum.
Do they use OFC wires or no?
What kind?
OFC, oxygen-free copper.
Never heard of it. Older wire is aluminum. Use caution. So use caution. Older homes in the 70s use it. It's about the 70s they like this stuff. It corrodes. It's bad. Use caution when stripping wire. Thank you for laughing. Because
It took me a second.
individual strands will break if nicked. Because strands can break when nicked. When replacing aluminum wire with copper, wire with copper, this is a Q&A question. With copper, a rule of thumb is to use 2 gauges smaller. And of course, that would be a larger number. If it's smaller wire, it's a larger number. So if you were replacing a 20 gauge, you could go down, sorry, if you had an 18, you could go down to, I was going to say 20, but actually it goes, you don't have odd sizes, so that'd be 2 sizes down, follow the rule of thumb, be 20 be 24, right?
18 to 22.
18, 20, 22, thank you.
Oh.
Provided
It's like a needle.
provided the new wire meets amp requirements. So it means you still have to check to make sure that it's going to handle the load. All right, wire is selected.
Why would you use smaller gauge?
It's lighter.
Oh. Oh. Okay.
And trust me, man, small plane, you will do anything you can to save a pound except
Lose it.
pass on a donut. Yeah.
Is the mil-spec wire what's on the motors and the lab?
Yes. Oh, wait, on the what?
The motors?
The engines.
The little motors that we have for landing
Little
gear.
motors.
Oh, yeah, it's mil-spec wire. Yeah, those came off Beechcrafts, so definitely. Wire is selected for components Components based on several factors. Components based on several factors. And this is according to Q&A. Per Q&A. That's my source. It's not much of a source, but there it is. Allowable power loss. Hey, if you've got a motor that's supposed to get 24 volts, and by the time it gets to the motor, it's only getting 20, you've had some power loss. It's not going to work well, which is the same, basically the same thing as saying this, permissible voltage drop. Current carrying capacity. Of the wire, obviously, and type of load, which would be continuous or intermittent.
Is that different from AC and DC?
Yes, definitely.
Very Q&A question.
All right, continuous or intermittent, it makes a difference. If, you know, like you're in the lab and you're running that little motor, you're running it continuous, you're running it intermittent. Intermittent. It's just a little bit on, not much. So we should define that. So per AC 4313, and remember that's Advisory Circular 4313, which is acceptable practices, methods, and techniques. Intermittent is a maximum of 2 minutes. So if it's something that's only operated intermittently, not very often, then the wire's not going to get as hot and you can run a much smaller wire. For example, if I'm running my landing light, is my landing light going to be on for 2 minutes, more than 2 minutes, you think?
Possibly.
Probably yes. Yeah, I'm not timing it, you know, or maybe I just want to fly and it's smoky out there. I'm just going to turn it on for safety. Well, I'm not going to check my watch and go, set a timer for 1:59, turn it off, back on. So that would be something that would be on a continuous load. Now, what about my flat motor? Now, if I'm running my flat motor for more than 2 minutes, we got some problems, right? That's only going to run for 15 seconds at a time. You know, bring it down, and there we go. I'm going to, you know, line up, go, and then bring it back up. So the flaps would be something that's intermittent, a landing gear, intermittent, but landing lights, other stuff like that, it's going to be different because it's continuous. So you have to be concerned with that. So then, obviously, continuous is more than 2 minutes. So intermittent is a maximum of 2 minutes. Continuous is then more than 2 minutes. All right, so we got that. I put this, also mechanical strength. Mechanical strength. Strength. And then I put in parentheses, so you know, although not the right answer, on Q&A. So there's one that's going to throw you off because mechanical strength is actually something that is considered. So if you read other publications, they're going to say mechanical strength is something you have to think about when selecting a wire. If you read your Q&As, it's not going to come up as that and it'll lead you down the wrong path, but it's not right. So wire that is too small will break. So I don't know if I shared with you that my airplane just came out of annual. The guy doing it took for frickin' ever. I wouldn't recommend him. Yeah, it was me. So Yeah, so now you get it. So anyway, so I took it for a flight, and one of the things that I did on my annual was I changed out the rod ends on the ailerons. They had a little bit of slop. So that meant the ailerons were going up and down and up and down and up and down a lot. So anyway, I changed those out, and I go for a flight, and everything worked, and I'm coming in to land at this airport, and I push my button on my yoke to talk, and I got nothing. I mean, there's no transmission whatsoever. I can see it on my audio panel that it's not working. So I'm like, oh, damn it. I got to think it through. I'm like, okay, so this switch was I took my headset out, plugged it over the co-pilot side, just reached over and hit that button. I could talk. But I go back and have to troubleshoot it. So what happens is I have a push to talk on my yoke, and the wires come through, and they go through a tube, and they go all the way down. They come out of the tube, and they wrap around. And those wires flex whenever I'm moving my yoke back and forth. And sure enough, over time, they had wore this little tiny hole through the shielding. It's not shielding, it's the plastic wrap, and then through the little wire. And so, okay, well, I guess I can see it. It's a ribbon, right? So it's a whole set of wires that are kind of stuck. You guys know what a ribbon of wire is. So they're all kind of stuck together. It's on the end. I'm like, well, shoot, how hard could it be? So I reach up in there, and of course I'm working like this, because you can't reach up in there. And I get them out, and I get one, and I get it, and I strip it out. I'm like, okay, I got an end, I got a strip. The other one, I just kept chasing it and kept going. And every time I would try and grab it, the wire would break. So finally I kind of gave up, and I called one of my guys who's in, should have called you. And I said, who did my radio install. I'm like, how do you fix that stupid ribbon, man? The thing just breaks because the wires are so small. He goes, yeah, you don't. The wires are too small, they just break. I'm like, okay, well, I concur. So he says, no, we run an external wire with a curly Q, it'd be fine. But anyway, so yeah, wire strength, that really matters. Using less than a 20 gauge wire requires special consideration. Special consideration in clamping to prevent breakage. So I know mechanics. I is one. And it's kind of like, it seems like in the aviation world, you're either an electronics wire person or you're not. And the sooner you recognize that, I think the better off you're going to be. You guys, you're kind of well-rounded. I mean, you do aviation stuff, but you specialize in. Am I right about that? It's like you don't want people like me around your wires, do you?
Well, you got mechanics there, and you're like, oh, I'll take care of it. You're good. They're like, oh, I can do it. I've done it before, and I'm like, it's just like one of those things where it's just like they don't work out with it as much, so it's just like you're more confident.
And what I'm thinking about is, you have a wiring problem, and so most mechanics, you have a wiring problem under the instrument panel, move the seat out of the way, you climb it there, well, let me see what's going on here. Let's see, that wire is going this way, and I got it, they're all bundled, and you guys spend a lot of time making them a real nice bundle. Well, this one comes over here, and you're just pulling it loose, and you're going, there it is, and you're just making a mess of things, right? And so you get these little 20 gauge wires, you're like, well, there's your problem. I got an open. Now, you just made a new problem, right? So, and guys that work with this stuff for a living, they have a little ohm meter out, and they're very, very careful what they do. And so it's watching people, and you realize that, Yeah, go ahead.
So, my last job, I worked for, I won't say where I worked, but anyway, the manager was an A&P, and he pulled a wire and it broke. And the way that he spliced it is not the recommended way to splice it. You got a universal butt splice and splice in. He used a solder sleeve, which is not technically wrong.
Yeah.
But yeah, you don't really want to use a solder sleeve to do it, because it can break easily.
That's the one where you put the two wires in and you heat it up and the solder melts inside of it. Yeah. Like a bus, when you clip it on, and I looked at him and I'm just like letting him do it. I'm just like,
He's my boss. I say something.
It's just one of those things. You don't know it. You don't know what it is you don't know, and then once you specialize in something, you really start to see small nuances. You know, like for example, the guy that put in my radio stack in my aircraft, that's all he's done his whole life. And his big thing is, I guarantee your radio equipment, or not equipment, but the wiring. He said, we guarantee your harness for the rest of your life. He said, anything ever goes wrong with it, we'll fix it. But you know, to that end, he's like, unless you start touching it, then all bets are off. But you know, it's because they know exactly how to do it. They don't take shortcuts. They don't put butt splices in, or you know. So it's just one of those things. Anyway, all right, back to this. So allowable things to consider. We had the mechanical strength, and then I did talk about allowable voltage drop. That's a big deal. Voltage, voltage drop. Or power loss is kind of the same word or same concept. And where this comes from, how you figure this out is 4313, table 11-6. Now let's see if we have that. 11.6. Well, there we go. What do you know? 11.6. Oh. Rheostat uses turn potential. Well, I should have had that a few hours ago. We explained everything. I tried to explain the little round thing with the wiper. There it is. All I got to do is remember what I have pictures for. Okay, so table 6, tabulation chart, allowable voltage drop between bus, you guys know what a bus is now, and utilization equipment ground. Okay, so nominal system voltage, and really this is your general aviation here, your 14, 28 volts. Remember, a 12-volt system is the same as a 14. People say that interchangeably. I could just say, I got a 12-volt system. Whoa, wait a minute. That's not even on here. Well, 12 and 14 is the same. 24 and 28 is the same. So allowable voltage drop continuous operation, which is how many minutes? 2. I can have a half or double it 1 for the 28. Intermittent operation, I can have a 1-volt drop or a 2-volt drop on a 28-volt system. Yes.
I'm sorry, you lost me with them being the same, because if it's with Ohm's law, if they're the same, that's going to be a completely different problem. So how does?
No, it's the system. So if I said, Harry, what kind of system do you have on your airplane? He's got a 24-volt system.
Mm-hmm.
Well, it's not on here, is it?
Yeah, but I mean, if I'm
The charging voltage of a 28 of a it's this. It means the same thing.
Yeah.
Because the battery is a 24-volt battery. It's a little more than, but the charging system has to put out 28 volts in order to charge the 24-volt battery. So your car, what voltage is your car? What's that?
14 point something.
It's 12, 14.
Well, it was
See?
a 14.2 is the last car. This truck I have no clue.
That's okay. That's word nominal.
Mm-hmm.
So it's nominal voltage is 14.
Gotcha.
But some people may say 12. They're not wrong. It's so just make sure you understand that. If we say something like, if I say a 24-volt system, which I'm prone to saying, I mean 28.
Yeah, I just didn't want to mess up because like if you said 24, and I might,
Well, no, if I'm
mix something together. And
if
I'll
you're
put the
doing
wrong
an
thing. Well,
ohm,
they're the same. And put the same number
if you're
in.
doing an Ohm's law problem, that's completely different.
Yeah.
But the system is either a 14, 28, or you can say 12 or 24. It means the same thing.
So utilization equipment ground.
Okay, so the FAA speak here. Allowable voltage drop between the bus, we know what a bus is, and the utilization equipment, the thing that's running's ground.
Okay, so that's through the thing too then.
Well, you got to go up to the thing, because if you go through it, then you're going to get a big voltage drop, right? So, and it's a weird way to put it. I don't know.
So basically from the bus to the
Bus to the load. They could have said load. Okay. So what do we got here? All right. Hopefully you wrote. I'm not going to write it down because there it is right there. Intermittent use, less than 2 minutes. We got that. Okay. So we can come over here. So allow a voltage drop. We have location considerations. It could be the wire itself could be running in free air. America, it's free air, which means just like nav lights come to mind because they're easy. Nav lights run in free air. There's usually one single wire that starts at the cabin, and it's the only wire that runs down the leading edge of the wing. It's all by itself. It's just kind of hanging out there, going out to the nav light because there's not much else on the wing. Sometimes you have strobes and stuff, but so that's free air. Or it could be in a bundle, which is where, like underneath the instrument panel, you may have a bundle, even on a small aircraft that's this big around with all kinds of wires going in there, all different sizes. And then we have to consider the temperature of the environment that it's in. So temperature. Why is it VIR? Oh, no. Whatever, we'll just go with it. Temperature. Temp. There, look, I'm going to write temp, and I'm going to save a bunch of time. And then I'm going to SeaWorld. I need to play that one, so remind me so everybody knows what I'm talking about. Has several charts. Charts. To help determine the max temp, and load carrying capacity. And that is actually table 11.9. Funny thing about the charts in AC 4313 about wire, this is good news, is for whatever reason, the FAA holds the A and P level to the very simplistic charts, which is wire run, length, amperage, voltage. Pick a wire, you're done. When you're an IA and on the IA test, it is the most complicated, convoluted thing I have ever had to deal with. You have to figure that out. Then you have to figure if it's in a bundle, free air, not free air. Well, you do continuous intermittent on your end. Then it's altitude. And it just gets all these, it just takes like an hour to figure out one piece of wire. Like, damn, that was rough. It was really, really difficult. But at the AP level, they don't make you do that. So it's just a very bizarre thing. And I believe that comes from the fact that at your level, you're working on general aviation. Well, even IAs do too, but this is more about air carrier operations. I just thought it was very interesting that at that level, they made me do that, but not at any other level. So determining the correct size of wire. Finally. We got 5 minutes left. All right. To select the correct size of wire, we will use chart 11-2 for continuous. I'll put continuous. Or 11-3 intermittent, INT, intermittent. And let me show you that. So 11.2. There we go. That should be it. There it is. Right there on the side. 11.2 and 11.3. Now here's where you're going to get messed up. They look exactly the same pretty much. Well, this is the same chart almost as this one. This one has these in here. These are examples. So if you pull up in 4313, it has examples, and these are the answers. They're examples to teach you how to use it while you're reading the book. But make sure you read continuous or intermittence. This is conductor chart continuous on this one, and the other one is not. Note that these charts keep from exceeding the maximum voltage drop, assuming one, wire is in free air. Here's the wire, obviously, based on conductor temperatures of 20 degrees to determine length. At higher conductor temperatures, use a formula. Talk about that. Tin-plated wire. So it's somewhat specific, so be careful with that. So free air, not in a bundle, and the wire is in an environment of 20 degrees Celsius, which, who knows what that is, but at 68 degrees Fahrenheit. So to do this, we must know three things. One, how to use a chart. No. You need to know voltage. V-O-L-T-A-G-E, voltage. We must know wire run in feet. Wire run in feet. And number of amps to be carried. So amps to be carried. All right, example 1. Let me see. A 150 watt landing light is to be installed in the wing. The distance from the bus to the light is 18 feet. The wire is not in a conduit or bundle, and the aircraft has a 28 volt system. All right, so which chart are we going to use? Intermittent or continuous? It's a landing light.
Continuous.
Continuous, I like that. Okay, so what do we need to know here?
Wire run, in feet,
Got the wire run in feet.
28 volt.
Okay, what, let's see. Amps, do I have amps on here? Shoot, what are my amps? Freaking Ohm's law. Give me a break.
Is that 150 watts?
150 watts.
5.36 amps.
5.36 amps. Okay. Now do we have everything? Voltage, wire on feet, amps. Okay. On the chart, follow the. So here's my voltage. Hopefully you can see that. So we're doing 28 volts. So it's going to be this line right here. All right. And by the way, right here it says voltage drop 741/2. Where have you seen that before? It's the allowable voltage drop right there in front of you. All right, so let me see. Here's my amps. It's kind of a tricky chart. So here's amps, 5 amps. So we're going to follow the 5 amp line down. I'll just draw it out there. 5 amp line down until it intersects the 18-foot line. So here's my feet, wire length in feet. So we got 14, 16, 18 is right here.
Are we able to zoom in at all?
Yeah, we
Can you cut the light off?
Only when you draw the line can I tell where you're at.
Can you cut the light off?
It's a little better.
See, continuous voltage, 28 volts. Here's the length in feet right there. So in feet, so 16, there's 18. So right there, so my intersection point, now I can't draw on it anymore. My intersection point is right there. All right, so it intersects the line. Now, follow that intercept point down to determine the wire size. So I'm right here in between. It's no, 20 to 22. All right, and it determines between the 24. Sorry, the 20 and the 22 there. I would select the larger of the two wires. 20, so we got 20. So did I do that right? 16, 18, that's the 5. Yep, 5 amps, there we go, right down there. So, that wasn't hard, right? Okay. All right, should we try another one?
On the second to last column, on the left side, you see that 16 and 20.
Nope, come back. Please stand by. There we go. Okay. Shoot, I don't know. Let's say we're running something with 10 amps, a 14 volt system, and it is 50 feet. Let's make it easy. So no Ohm's law necessary. I got all 3 things I need, right?
Yes.
Okay. Zoom in. So I forget what it was. 14 volt.
Yeah.
Okay, so we're on this 14 volt here, 50 feet. So we're going to be in this line right here. And,
10 amps.
ooh, that works.
Right there.
Right there. Yep, 10 amps. 10 amp intersect right there. So just follow it down. Right here. So which size wire? 8 gauge. All right.
Okay.
That's pretty easy. Now, If you're working with AC 4313, they have examples right in there, so you can do that. Well, but you're not going to get to open AC 4313 while you're doing this. But, oh, here it is. Like a number 8 wire at 20 amps. Let's take a look at that. Number 8 wire. Number 8 wire is running 20 amps. Yep. Number 12 at also 20. Yep. That one at 20. Okay, let's do this now. See if we can get this knocked out. All right, so what if it's over 20 degrees? So, let me see. Oh, good Lord. What is the maximum length of wire? Maximum length. Now I need to know how long the wire is of a number 8 wire. Number 8 wire that can be used for a 28 volt system at 50 amps. What's the maximum length of number 8? And we'll use the continuous. So where's my wire? Right here. So it's this line here. I don't know, should I enlarge it?
No, this is the red line.
You okay? Okay, so number 8 wire, 28 volt, this one here,
30 feet.
and 50 amps.
30 feet.
So what's my maximum run? So here's the intersection, so I'm just going to come over to here. And 15? Why not?
The 20.
Because it's that one, 28 volts, so 30 feet is the most I could bid. All right, what if, let me see, what if the max temperature is 50 degrees Celsius? Do I have time for that? I really don't. So here's where we're going to have to pick up tomorrow. Talk about that one. So we'll not have a test tomorrow. All right, let me pause this.
We're not having a test. We're having a